Hi, this is Saurabh Verma. I'm going to explain my MTech thesis project on machine learning based spatial reviews for the wireless network. Uh, this project uses a spatial reviews to enhance the wireless network performance in the dense environments. The main objective of the spatial reviews operation is to maximize the utilization of the medium by increasing the number of parallel transmissions. This project explains the implementation of the spatial reviews in the wireless network using the multi and bandwidth algorithm. This project is basically using the multi and bandwidth algorithm to implement the spatial reviews technique in the wireless network to enhance the performance of this wireless network. Now coming to the related work, as shown by the previous work, the optimal decentralized spatial reviews in the wireless network through TPC and DC is very hard to be derived analytically, and mostly because of the adversarial setting and the lack of information at the node. The existing decentralized solution barely provide flexibility with respect to the scenario so that the potential use cases are described. For that, we focus on online learning and more precisely multi-arm bandit algorithm. The multi-arm bandit framework allows to reduce the complexity of the spatial rules problem since detailed information about the scenario is not considered. In contrast, learner gain knowledge on all the adversaries as well, thus facing a single environment. Now coming to the wireless network. So wireless network is a computer network that uses wireless data connection between the network node. Example is like wireless network sensor, wireless sensor network, satellite communication network, etc. These are the types of the wireless network depend upon the use of wireless network. Now coming to the spatial reach, this technique is basically used to enhance the parallel communication in the wireless network. This spatial is defined by the ratio between the co-channel transmitter and the transmit receiver distance. Now, why to use the spatial reach? To increase the parallel communication and to increase the performance of the dense network. Basically, there are two methods to address the spatial reuse. The first one is the OB SSPD spatial reuse, and the second one is the parameterized spatial reuse. These are the two methods we are using to address the spatial reuse using the multi-arm bandit algorithm. Now coming to the multi-arm bandit algorithm, this is the reinforcement learning algorithm. Uh, and there are four types of multi-arm bandit algorithm we are using to implement the spatial reuse technique. First one is the Epsilon greedy algorithm, second one is the EXP3 algorithm, third one is the UCB algorithm, and the fourth one is Thompson sampling algorithm. I'm using all these four algorithms to implement the spatial reuse technique. Now coming to the first algorithm, epsilon greedy algorithm. This is the simplest and the most popular multi-arm bandit algorithm. The value of epsilon determines the fraction of the time when the algorithm may explore available arm and exploit the one data performed the best historically the rest of the time. The, there are two operations, exploration and exploitation. In exploration, we choose the random action to pool with the probability epsilon, and exploitation we choose the best action to pool with the probability 1 minus epsilon. I have shown this pseudocode of this epsilon greedy algorithm here, in which we choose the parameter epsilon between 0 and 1, and accordingly we will choose the action and we will get the maximum reward, the action with the maximum reward. Now coming to the EXP3 algorithm, this is more like a traditional machine learning algorithm. Uh, EXP3 algorithm attempt to be an efficient learner by placing more weight on the good arm and the less weight on the arm that are not promising. The algorithm starts by initializing a vector of weight w and each weight initialized to equal to 1. It also takes as an input an exploration parameter which control the algorithm likelihood to explore arm uniformly at random. I have shown this EXP3 algorithm here where we are taking the input parameter gamma between 0 and 1. We are setting the initial weight equal to 1, and we are calculating the probability pi of t, and accordingly we will choose the action with the maximum probability and we will get the reward, and then we will update the weight wi of t plus 1, and we will is we will repeat this step and we will get the reward. We will get the action with the maximum reward. Now coming to the ECB algorithm, this algorithm is described as the optimism in the face of uncertainty, and given a history of the reward and number of pools for each arm, the ECB algorithm calculate an upper confidence bound which it used to decide which arm to pull. So upper confidence bound algorithm were introduced as a class of bandit algorithm that explore more efficiently. Despite being uncertain about the estimated mean of the distribution of the k-arm that each step empty, it always select the arm I that maximize the sum of the estimated mean of arm I. Now here I have shown the ECB algorithm pseudocode where we are choosing one action at a time t and we are getting the reward, and accordingly we are updating it, and we are after repetition of the sum steps we will get the maximum rewards. Now coming to the Thompson sampling, here up to until now all the method we have seen for the tackling the bandit problem have selected their action based on the current average of the reward received from the those actions. Now, Thompson sampling algorithm takes slightly different approach. This algorithm built up the probability model from the obtained reward and then sample from this to choose an action. For every arm, start with the prior belief on parameter of the distribution. On making observation from an arm, update the posterior belief. At time t, play every arm with the posterior probability of being the best arm. I have shown this Thompson sampling algorithm where we are we are taking from the we are sampling from the beta distribution, and accordingly we are choosing the action, and we are getting some rewards, and accordingly we are updating the beta distribution, and we will repeat this step according to this schedule of the Thompson sampling, and we will get the action with the maximum rewards. Now, coming to the conclusion, in this work, I have studied the implementation of the multi-arm bandit algorithm to address the decentralized spatial dense wireless network, and I focus on situations with limited resource to highlight the competition issue raised by the adversarial environment. I investigated the trade-off between the fair resource allocation and the high temporal throughput variability in the explain greedy EXP3 ECG and Thompson sampling algorithm. Now, apart from this, we discovered that Thomson sampling outperformed the other method since it captures useful information from this chaotic setting. We have also explained the phenomena to the fact that both the ECV and the Thomson sampling take into account the probability distribution of the reward rather than just their magnitude. Now coming to the future work, we have left as a future work to study the application of the multi-arm bandit to wireless network through distributed and the centralized system with shared reward. We can explain this work to improve throughput and stability by inferring opponent's behavior and adjusting accordingly and studying the dynamic circumstances. Thank you.